March 27th, 1964, Whittier, Alaska. 16 Caterpillar D7s are sitting on a cold beach beside Prince William Sound. Unloaded but going nowhere. The port behind them is still standing in places, but it has already stopped functioning as a port. The machines were not abandoned by choice. Something in the chain had failed first. To understand why 16 Caterpillar D7s ended up sitting useless on a beach at Whittier, you have to go back to the way that port functioned before March 1964. Whittier was not just another small Alaska harbor. It was one of the most important military and freight gateways in south-central Alaska, a narrow coastal outlet tied to the interior by rail, hemmed in by mountains, exposed to Prince William Sound, and built to move cargo with very little margin for disruption. If freight reached Whittier, it could move inland. If Whittier failed, the supply chain did not bend much. It broke. That mattered in Alaska more than it would have anywhere on the lower 48. Distance was already a constant problem. Weather was already a constant problem. Terrain was already a constant problem. Ports, railheads, and machine yards were not interchangeable pieces in a broad network. They were fixed points. Lose one, and the consequences spread fast through every job that depended on it. By early 1964, Caterpillar D7 tractors were a familiar part of that system. The D7 was not the largest crawler in Alaska, but it was one of the most useful, big enough to push, pull, clear, and grade in rough country, small enough to transport more easily than a D8 or D9. It fit the kind of work Alaska demanded: road approaches, rail support, dock work, military handling, construction staging, and emergency clearing when weather or ground conditions turned against men on the site. Depending on configuration, a D7 of that era weighed roughly in the mid-20,000 pound range before attachments, with enough drawbar pull and blade capacity to make it a true working standard rather than a specialty machine. That is what makes the Whittier story so specific. These were not museum tractors. They were not already derelict. They were active machines inside a logistics system that assumed the port would keep functioning. The machines were there because someone expected them to move onward, to be unloaded, staged, transferred, or put to work through a harbor that had done that job before. Then came March 27th, 1964. The Great Alaska Earthquake struck at 5:36 in the evening. Moment magnitude 9.2. The strongest earthquake ever recorded in North American history. It lasted long enough for structures to fail in stages, long enough for ground behavior to change while people were still trying to understand the first movement, long enough for waterfronts across southern Alaska to stop behaving like solid ground at all. Whittier was one of the places where that change became brutally visible. The town's waterfront infrastructure was hit by violent shaking, ground deformation, and the sea effects that followed. Docks, pilings, approach structures, cargo surfaces, and rail-connected handling areas were no longer dealing with ordinary load. They were dealing with a sudden loss of alignment, support, and trust. On paper, a port can survive partial damage. On the ground, a port becomes useless much sooner than it becomes completely destroyed. That distinction matters. A port does not have to vanish to stop working. It only has to become uncertain. If the dock face has shifted, if the pilings have failed, if the apron has dropped, if the rail approach is out of line, if the subsurface has lost bearing strength, then every ton brought in becomes a gamble. Cargo handling stops before collapse is total, because no one can safely predict what the next load will do. Mechanically, the problem was this: heavy equipment depends on load paths. A machine rolling off a ship, across a dock, and onto shore is putting concentrated weight through tracks or wheels into a structure designed to distribute it. Earthquake damage interrupts that path. Timber cribs separate, fill settles, piles rotate, decking loses support. The machine may still weigh the same, but the structure beneath it no longer behaves the way the drawing said it would. What had been a working port hours earlier could become a trap for cargo, crew, and machinery by nightfall. In the aftermath, Whittier was no longer a reliable transfer point. And that created a problem larger than the damaged waterfront itself. Machines and freight were still arriving into a disrupted system. Alaska still needed equipment. Recovery still needed steel, fuel, and tracked tractors. But the normal handoff between ship, dock, rail, and inland destination had been broken. Somewhere inside that logistical rupture, 16 Caterpillar D7s reached the wrong place at the wrong moment. They could be delivered to the shoreline. They could be put off where ground access still existed. But they could not continue through the port in the normal way, because the port was no longer functioning as the system expected. The machines were not abandoned because nobody wanted them. They were left because the chain beyond them had failed first. That is the core of the story. When viewers hear that 16 bulldozers were left on a beach, the first assumption is neglect, rust, bad planning, some forgotten government surplus yard by the water. But Whittier was different. These tractors were stranded by a broken interface between sea transport and inland movement. The earthquake did not simply damage buildings, it disconnected steps in a machine's journey. And once that happened, the beach became a holding yard nobody had planned for. The setting made the problem worse. Whittier was boxed in by steep terrain, exposed shoreline, and limited transport options even in normal conditions. There was no wide industrial backland waiting behind the port, no easy rerouting around the damage, no spare harbor next door with open rail access and intact cargo surfaces ready to absorb the load. Every damaged element increased pressure on the next one. If the dock was compromised, unloading changed. If unloading changed, staging changed. If staging changed, onward transport slowed or stopped. And heavy tracked machines do not disappear while paperwork catches up, so the D7s sat where the system could still place them, but not move them farther. By then, the operation had changed from delivery to storage, and from storage to uncertainty. Salt air started its work immediately. Tides, spray, wet gravel, and cold coastal exposure do not destroy a caterpillar overnight, but they begin the process at once. Seals age, exposed steel flashes with rust. Electrical systems suffer. Track frames and rollers collect abrasive grit. A crawler parked near the sea is not resting. It is being slowly taken apart by the environment, one surface at a time, and still, moving them was not simple. Each tractor represented tens of thousands of pounds that now required a new route, a new loading method, and a stable structure somewhere in a damaged region that had very few of those left. On paper, the machines could be recovered. On the ground, every step depended on infrastructure the earthquake had already compromised. That is how a fleet becomes still. Not through one dramatic order, but through a series of broken connections no one can solve quickly enough. At Whittier, after the 1964 earthquake, 16 Caterpillar D7s ended up on the beach because the port that was supposed to move them inland had ceased to function as a port. And once they were there, the question was no longer how to deliver them. It was how long they could remain before the coast began to claim them. What happened next was not a mystery of luck. It was a matter of steel, salt water, damaged infrastructure, and time. In the first hours after the earthquake, Whittier was dealing with far more than stranded machinery. The entire region was in shock. Communications were disrupted. Waterfront damage had to be assessed in real time. Rail connections, dock faces, storage areas, and cargo surfaces all had to be treated as suspect until someone could prove they were stable. In that kind of environment, 16 Caterpillar D7s sitting on a beach were important. But they were not the first emergency. Human survival, access, fuel, medical movement, and basic transport came first. That delay mattered. A crawler tractor can survive neglect longer than most machines, but coastal neglect is different. Salt spray works into exposed linkages, blade cylinders, control levers, track pins, and every unprotected edge where paint has worn thin. Bearings do not have to be submerged to begin suffering. Sheet metal does not have to fall off for corrosion to start eating into the machine's future. The D7s had been built for hard work, not for static exposure on a tidal shoreline in Prince William Sound, and yet they remained. The reason was simple. Recovery required the exact thing the earthquake had damaged most: a dependable chain of movement. To save the tractors, crews needed stable loading ground, working lifting capacity, or roll-on capacity, intact transport coordination, and a destination prepared to receive them. Each one of those steps depended on infrastructure already under strain. A single D7 was manageable. 16 of them, in a disrupted Alaskan port, became a logistical problem large enough to keep slipping down the priority list. Then the margin disappeared. Once a machine sits long enough in a place like Whittier, recovery stops being just a transport issue and becomes a condition issue. Fluids degrade, fuel systems contaminate, track assemblies stiffen, electrical components corrode. Every week of exposure makes the next move harder, because the tractor is no longer just heavy cargo. It is becoming a partly disabled heavy cargo. The machine that could once drive onto a transport now may need towing, winching, cribbing, or partial mechanical intervention before it can move at all. That is the hidden shift in stories like this. People imagine abandonment as a single decision. More often, it is a sequence. First, the machine is delayed. Then it is exposed. Then it is harder to move. Then the cost of moving it rises. Then someone decides the effort belongs somewhere else. By the time that process is visible, the abandonment has already happened. Mechanically, the D7 was still a durable tractor. Caterpillar had built the model to withstand punishing field conditions. And that durability is part of why the image of those machines matters now. A D7 could take shock loads, rough grading, cold starts, and hard pulling better than most equipment in its class. But durability is not immunity. Tracks and final drives do not benefit from sitting in wet coastal aggregate. Steering clutches do not improve in salt air. Seals do not preserve themselves while a machine waits for a transport plan that never fully comes together. Now back to the site. On that shoreline, the tractors had become something they were never meant to be. Fixed objects. Heavy equipment is supposed to convert fuel into movement. It is supposed to change the ground, not be claimed by it. But the beach at Whittier had turned active machines into stationary inventory, and stationary inventory into exposed relics. The same weight that made them useful now made them difficult. The same steel that made them durable now made them expensive to recover once corrosion and delay entered the equation. Some were likely stripped for parts over time. That is what often happens when stranded equipment outlives the urgency that once surrounded it. Batteries disappear, gauges vanish, small serviceable components are removed first, then larger assemblies if access and need justify the labor. A machine left in the open becomes a parts source long before it becomes a historical artifact. The men looking at those tractors would not have seen romance in them. They would have seen usable steel, scarce components, and a problem that had become more expensive than the machine's immediate value. That is why the story carries weight beyond the number 16. These D7s were not lost because they were weak machines. They were lost because the system around them failed at the wrong moment. The earthquake did not have to destroy every bulldozer directly. It only had to break the route, the timing, and the confidence needed to keep them moving. Once that happened, even a proven crawler tractor could become surplus to the emergency in front of it. The physical lesson is clear. Machines do not operate alone. They depend on roads, docks, railheads, fuel supply, labor, spares, and decisions. When people tell industrial history only through projects and disasters, they miss that point. But when the story is told through the machine, the dependency becomes visible. A D7 on a beach after the 1964 Alaska earthquake is not just a strange image, it is evidence of a broken logistics chain. And that is why Whittier matters. The earthquake of March 27, 1964 reshaped more than coastlines. It exposed how fragile critical transfer points could be in Alaska's operating environment. Ports were not abstract assets. They were machine gateways. When one failed, the effect reached beyond freight manifests and repair budgets. It stranded tractors, delayed clearing operations, complicated recovery, and forced crews to improvise under conditions the original transport plan had never anticipated. The site is quiet now compared to what it was in the spring of 1964. The violent motion is gone. The emergency traffic is gone. The immediate confusion that followed the quake has long since passed into reports, photographs, and memory. But the underlying lesson remains. Heavy equipment can survive punishment. What it cannot survive indefinitely is disconnection from the system that gives it purpose. The machine was not supposed to stay there. That is the point. It was supposed to move inland, work, wear out in service, and be remembered only by the men who ran it. Instead, the earthquake interrupted that future and left the tractors in a place where movement stopped. The coastline became the end of the line. The machines are gone now, or scattered into scrap, parts, and undocumented afterlives. The beach did what beaches do. Salt, weather, and time reduced urgency to residue. But the story remains because it captures one of the clearest truths in American machine history. Power means very little when the ground, the port, and the route beneath that power all fail at once. That is why these Caterpillar D7s still matter. They show that in disaster, the machine is never just the machine. It is the cargo system behind it, the operator who expected to receive it, the damaged dock that could not pass it forward, and the narrow stretch of Alaska coast that held it longer than anyone intended. 16 tractors on a beach sounds like a footnote. In reality, it is a record of the moment when one of the strongest machines of its class met a logistical failure it could not push through. And this would not be the last time heavy equipment in Alaska was stopped not by lack of horsepower, but by the collapse of the ground, the route, or the structure beneath it.